At the University of Iowa Center for the Book Paper facility, we are engaged in the production of a variety of Western handmade papers. While some are used in limited edition book printing or fine art applications, most are designed for use in the conservation of rare books and works of art on paper. Our conservation papers are primarily end papers and heavy cover stock for paper case bindings. This videotape follows the production of 3 of our papers from fiber to finished sheets. Our primary raw material for Western papermaking is dew-retted flax fiber. To make processing easier, this particular grade has been custom cut to 6 millimeters or 1/4 inch. When making white book paper, we use new unbleached muslin textile cuttings or Cheney 865, a commercial unbleached muslin rag half stuff. On rare occasions, we also use Abaca sheet pulp. In general, we prefer to follow a traditional approach by preparing raw fiber by hand. This flax fiber is being dumped after a 10-week fermentation in a 0.1% calcium hydroxide solution. Fermentation is the first step in making our B9 book paper. The step removes some of the non-cellulosic material on the surface of the fiber. More important, fermentation leaves the fiber receptive to beating and allows the production of softer papers with excellent formation quality. To stop fermentation, swell the fibers, and help remove remaining non-cellulosic materials, the fiber is cooked in a 0.4% calcium hydroxide solution. Because the fermentation solution becomes acidic near the end of the 10-week ferment, cooking in lime also assures an alkaline pH in the finished pulp. Roughly 1 liter of lime cooking solution is required for every 60 grams of dry fiber. Cooking continues for 3 hours with mixing every 30 minutes. After the stove is turned off, the fiber will be left to stand and cool. The cooked fiber is scooped out of the kettle and dumped into a rolling cart. The cart is lined with plastic gridwork covered with plastic mesh. As the spent cooking solution drains through the mesh, it passes through holes in the bottom of the cart. A hose is used to give the fiber a preliminary wash from above. Water used during the various papermaking steps comes from a nearby well, is alkaline, and has been filtered to remove iron, chlorine, and particulate matter. In the beater room, we have 2 machines. The larger beater is turned on and the fermented and cooked fiber is added. Once the entire batch is in, a drum-type washer is lowered into the beater tub and turned on. Only minimal beating action takes place for the better part of a day. During this time, a small but continuous stream of fresh, clear water is let into the beater tub. The washer is set so the lower portion is immersed in the circulating pulp. As water accumulates in the tub, dirty water is gathered up by the rotating washer and dumped down a waste pipe. As a result of continuous washing, the color of the fiber changes from a brownish green to a light off-white. Before the invention of chlorine bleach, washing during beating was the standard method used in paper mills to keep the pulp light in color. Today, drum washers can be used for the same purpose, as well as to rinse away residual chemicals after cooking. After the fiber has been well washed in the large machine, it receives final treatment in a smaller finish beater. Compared to the fermented and cooked fiber, the finished washed and beaten fiber on the left is much shorter and lighter in color. At this stage, the pulp is ready for making our B9 book paper. While considering the pulp prior to sheet forming, it is informative to compare all the pulps we have prepared for this tape. The white pulp on the right is made from Cheney 865, the commercial unbleached cotton muslin half stuff shown earlier. This white fiber received no special treatment prior to beating. During beating, it was washed lightly, followed by addition of 3% calcium carbonate and a retention aid. Removing the stick from the beaker so the fiber drapes over its edge gives an indication of the length of the fiber. Next, the B9 fiber prepared from raw flax. And finally, a blue pulp made from the same raw flax fiber which was not fermented but cooked in lime, washed lightly during beating, and colored with blue and black pigment and a retention aid. Since it will be used to make a tough, supple sheet for paper-cased bindings, the fiber is purposely left exceptionally long. This produces a good combination of tear resistance and fold endurance. The B9 fermented flax pulp has been added to the vat and sheet forming is underway. We are using a 55 by 75 centimeter mold and decal. Each successive sheet is transferred to a damp felt in a step called couching. Notice how the person at the vat works carefully to make sure the far edge of the mold does not go under the surface of the vat mixture. If it did, the suction of the mold coming out of the vat would add to the already considerable weight of the mold and pulp. There are as many different sheet forming styles as there are paper makers, so it is not essential that these particular motions be duplicated exactly. Nevertheless, it is useful to watch how a sheet is formed. As the mold comes up and out of the vat, it is quickly leveled. Slight jerks or shakes are used to disperse the pulp and even the formation. The proper shake, as it is called, varies with pulp and vat person. As water passes through the porous surface of the mold, the sheet solidifies. Formation of the blue sheets for paper-cased bindings follows a similar routine. A much higher concentration of fiber and a deeper decal are used. Both of these contribute to making the heavyweight finished paper that is required. Note how high the pulp stands when the decal is removed. In this case, almost 3/8 of an inch, or 8 millimeters. Lifting the mold out of a vat of this type of pulp requires strength and control. Using two molds allows us to let the thick sheet drain longer before it is couched. Each sheet in the pile is separated from the next by an interleaving felt. Couching is a delicate operation. Care is taken to turn the mold over and set it down along a width of the leading edge of the fresh sheet. This helps anchor the new sheet to the felt, so the remainder of the couching action can be continued without distorting or crushing the sheet. When large quantities of white book paper are needed, we produce sufficient pulp to charge our automatic pulp delivery system. This combination of machines and interconnecting pipes is modeled after systems used in European mills, where handmade papers are produced in large quantities. Each time a sheet is formed, the vat person pulls the overhead cord to let more pulp flow from the storage tank. The pulp passes through a flexible tube pinch valve and into a knotter, in this case, a flat diaphragm screen. When the screened fiber enters the vat, it is mixed by an agitator, which turns continuously at the bottom of the vat. The rotating drum, which works exactly like the washer on a beater, removes excess fresh water from the vat and returns it to the knotter. This fresh water supply is crucial to keeping the fiber flowing smoothly through the knotter. When all equipment is in operation, a two-person team equipped with two molds and a decal can make paper continuously without having to stop to add pulp or mix. After a stack or post of some 20 sheets has been accumulated, it is carried to the press. Our press is capable of generating 200 tons of pressure, but we generally use only about 50 tons. This amount is more in keeping with pressures generated by common screw presses during the history of the craft. Papers pressed at 50 tons are harder to handle, but they pick up more of the marks that later serve as subtle evidence the sheet was made by hand. This step, and those that follow, are identical for all of the papers being described in this tape. Once removed from the press, the sheets are parted from the felts in a routine called laying. Our felts are an industrial wool, true felt material used to help obtain surface qualities similar to those of high-quality historical papers. The damp sheets are stacked together in staggered groups of roughly 8 sheets called spurs. When making the heavy blue sheets, each spur contains 4 sheets. When a papermaking session has ended, the spurs are restacked with a damp felt between each. Care is taken to make sure each spur sits squarely on top of the one below. This accumulated pile is then returned to the press and given enough pressure to make the paper drip or weep. This will make the sheets in a spur stick together, but not so tightly that they can't be easily parted after drying. The damp spurs, both cotton and heavy blue flax, are hung up to dry along with the felts. The spurs of paper are purposely hung with a bow to allow for shrinkage during drying. The vast majority of our papers are loft dried. The finished sheets are more supple, stretch or give more when sewn through, and have a slightly rougher surface texture. In general, these characteristics are preferred in conservation applications. The alternative would be to dry sheets between blotters under pressure. This would produce qualities of stiffness, smoothness, and dimensional stability that can be desirable in fine art or other applications. This drying rack is based on a Canadian rack, which in turn is common to European versions. Sometimes a small wooden lever or catch is used instead of a marble. In either case, the paper is hung with minimal marks left in the sheet. Once the paper has dried, it is taken down and the spurs are parted by dividing each in half, and in half again until a stack of single sheets has accumulated. To flatten the dried sheets, 2 different approaches are taken depending on whether or not the paper is book weight or heavyweight. In both cases, the paper is first humidified by spritzing each sheet on both sides with a garden mister or fine spray hose nozzle. The dampened pile is wrapped with sheet plastic and left all day or overnight. This has a humidor effect, and in time, all areas of each sheet relax and become pliant. The heavyweight sheets are removed from the plastic and restacked on top of a wad of about 10 felts. 10 more dry felts are added on top, and the pile is pressed at 50 tons of pressure. This serves to stretch and flatten the paper slightly. The damp sheets are then removed from the press to be hung to dry in groups of 2. Later, after the dry sheets are again squeezed briefly at 50 tons in the hydraulic press, they are loaded in the screw press to stay under pressure overnight. The next day, after the blue sheets have been removed from the screw press, they are dry and flat but retain much of their natural loft-dried surface and a bit of edge cockle. The procedure for bookweight paper is slightly different since it tends to crease if treated like the heavy paper. After humidification under plastic, the book paper is loaded into a stack dryer. Several sheets are placed between heavyweight blotters, which in turn are sandwiched between tri-wall corrugated board. The sandwich is repeated until all the damp book paper has been loaded in the stack. A plastic sheet is used to block the remaining open space above the stack. Cement blocks are added to the top to keep a constant pressure on the pile as the paper dries. Within the stack, the moisture in the damp paper is drawn into the blotters, and from the blotters into the corrugated board flutes. The air in the flutes carries off the moisture. The end effect is that the handmade paper will be re-dried flat while it is kept under pressure. As a final step, the fan is turned on to increase airflow through the flutes. After a day or two, the paper can be removed. On occasion, particularly in sheets made from highly beaten fiber, the re-dried paper will come out with edge or internal creases. Usually this method flattens sheets while retaining much of their loft-dried surface and a slight amount of edge cockle. We rarely dry paper in the stack dryer fresh from paper making, partly because of excess moisture which soaks into the blotters and board, but mainly because we feel the finished sheets come out too flat and stiff. Photo-grade gelatin is weighed out in preparation for sizing. Gelatin external size will improve a paper's resistance to abrasion and the penetration of liquids. It will also make a substantial improvement in the paper's fold endurance. The granular gelatin will be poured into a volume of cold water yielding a 2.5% solution concentration and is allowed to stand overnight. Prior to sizing, the solution is heated in a double boiler to approximately 45 degrees centigrade. Alum water is added to the warm solution just before it is transferred to the sizing tray. The paper is added to the warm solution one sheet at a time. In this instance, we are sizing a red version of the heavyweight blue paper made earlier. Sizing is normally done after spurs have been parted into individual sheets, but before any humidification or reflattening. The alum water added to the gelatin solution represents an application rate of 1% alum based on the weight of the dry gelatin. At this concentration, the finished paper will have an alkaline pH. We believe alum hardens the gelatin and leaves the finished paper more resistant to biological attack. Once a stack is accumulated, the pile is rolled with a piece of plastic pipe to smooth the sheets and work out air bubbles. 2 wooden sticks are used to grasp the end of the stack. The tray is tipped toward the sticks to provide a deeper bath where the sheets bend as they leave the tray. The sheets are transferred to a felt resting on a board. As the size cools, it can begin to solidify in the pile, so an effort is made to complete the application of the size in about 15 minutes. The process is repeated until paper, sizing, or time runs out. After the last group of sheets is added to the pile, it is transferred to a screw press and gently squeezed. This evens the distribution of the size in the paper and expels the excess. The solution is caught by the large photo tray underneath the lower press board and allowed to drain out a small hole into a bucket for reuse. After draining a minute or two, the sheets are removed from the press to be parted and hung as single sheets. The next day they are fully dried and will be taken down to go through the same reflattening steps described for the blue paper. When we want a certain smoothness or shine in the surface of the finished paper, we burnish the paper by hand. The effect can be seen in these dark sample sheets. The regular sheet is on the left. The burnished version of the same paper is on the right. Our burnishing tool is a piece of plate glass with a wooden handle glued on top. The edges of the glass have been rounded slightly by working the glass against a belt sander. Burnishing is accomplished by stroking the sheet repeatedly with the tool to obtain more or less shine. One or both sides can be done, depending on the paper's end use. Finished sheets will be graded by thickness and then quality. In judging quality, the surface of the sheet is checked by reflected light for defects. The sheet above suffers from many more defects compared to the higher quality sheet below. Later, sheets are checked by transmitted light for improper couching, poor shake, and other defects as shown in this sheet. compared to this generally well-executed sheet. In making book papers, we are striving for a look and feel that emulates related properties in the best early European papers. These include some contradictory characteristics, such as a very active but not overly rough surface, a toughness combined with pliancy, and evidence of careful workmanship in the midst of inconsistencies. We have found that the only way to get closer to the qualities we are after is to continually compare our sheets with the early papers. Similar issues are involved in making heavyweight sheets for paper case bindings. The better historical models often have a smooth, abrasion-resistant surface, yet seem quite supple. We are working towards sheets that are user-friendly, both for the binder and the reader of the book. If we are successful, the finished book will invite being handled and read. At the University of Iowa Center for the Book Paper Facility, we are combining research on early papers with production experience and experimentation to revive old techniques and develop new methods. These efforts are designed to benefit a variety of related fields. We welcome inquiries from prospective students and contact with fellow researchers in paper and book-related studies.